Okay, so we're going to look at lesson 7.1, characteristics of logarithmic functions with base 10 and base e. So we're going to explore how log base 10 of x is different or the same as 10 to the power of x. So we're going to actually graph both of them on our calculator. Now, what's really important to notice is that the base of 10, you do not have to write. So whenever you see this little 10 there, you can just write it like this, and it means the exact same thing. Okay, so we're going to go to our calculator and write 10 to the power of x. And on the same graph, we're going to go log, which is log, so that's the button on your calculator, log, try to find that, x. So 10 to the power of x, and we have log x. So we're going to change our window to the standard window, of course. So those are the values, -10, +10 for your min and your max, and then your scales are 1. Graph it, and you should see something like this. So the only thing that I would change here, guys, is that this red graph should actually extend downwards forever. So it should actually continue downwards, just like that blue one. So what you want to notice is that the graphs are actually they're mirror images of each other if you look diagonally at each other. So these are mirror images of each other. Okay, so what I'm going to do is graph this and show you the images. So one graph will look like this, with arrows on either end, and the other one will look like that. So this is what your y equals log of x is, and this one is your y equals 10 to the power of x. So what's different and what's the same? We're going to compare them just to show you kind of how they look. So 10 to the power of x versus log of x. Well, with our characteristics, remember our y-intercept. When we look at the y-intercept of an exponential function, the y-intercept would be 1. Versus, there is none. There's no y-intercept when we look at the logarithmic function. It should not touch the y-axis. And then our x-intercept in this one, there's none. For log of x, we should find that the x-intercept is equal to 1. The domain should be xer, x such that xer. And then the domain for this one should be x is greater than 0, xer. Our range would be y is greater than 0, yer, when it comes to our 10 to the power of x, versus our range is going to go forever downwards and upwards, so we're going to just say yer in general. That means it goes on forever in both directions. The end behavior for an exponential will go from 2 to 1. So it starts in quadrant 2, goes to quadrant 1. And then our logarithmic in this one, it goes from quadrant 4 to 1. So this one is increasing, so it's going from 4 to 1. If it's decreasing, you'll actually notice that it goes from 1 to 4, so it will switch. So that's something to consider. So this one, they're both increasing in both these cases. So this one's increasing, it's going from 4 to 1. And then it's decreasing if it goes from 1 to 4. So for each of the following, we are going to graph them and just write the characteristics. So 15 log of x. So as you can see, this one's increasing with the x-intercept being 1. So that's what it looked like. So I'm going to actually sketch each one, and then we'll talk about each one individually. So now I'm going to go -5 log x. So that one's decreasing. -4 ln x, you just have to look for that ln button, so that's the only difference with the next one. So -4 ln x. Okay, so if you look at your calculator, look for the ln button. So it should look like that once you put it in, but it still looks like a decreasing logarithmic function, so that doesn't change. And our last one, 12 ln of x. 12 ln of x. Graph it, increasing. Okay, so in this case, the y-intercept, there's none. In all of them, the y-intercept does not exist. X-intercept, in all of them, they're 1. Every single x-intercept is 1 in all these cases. The domain for all of them will be x such that x is greater than 0 xer. And the range is going to be forever going up and down, so we say yer. So that's going to be the same for all of them. So this one, the first one is increasing. So you'll notice that the quadrant, it starts in quadrant number 4 and it actually goes and finishes in quadrant 1. So increasing ones will do that. So this one is increasing as well. So we're going to find that it goes from 4 to 1. Versus the decreasing ones, you're going to notice that the negative in front of that logarithmic function, ln is just a natural, like the natural logarithmic function, so that's a way of writing it. But when they are decreasing, you're going to find that negative in front, and it's going to go from quadrant 1 to 4. So this one also from 1 to 4. Okay, so that's the only difference between the increasing versus decreasing ones. And our last example, we want to do the matching. So again, you should pause the video, try this on your own, see if you understand and can do it without a graphing calculator, and then unpause and check if you get the same answers. So I'm going to give you the answers right now. So in these cases, they're giving us exponential versus logarithmic ones. So I'm going to start with the 1 and 2, the logarithmic ones. So this one's an increasing one because of the 2. And this one's a decreasing logarithmic because of that 0.1. So increasing will be this one. So this one has to be 1. And then decreasing logarithmic will be this one right here, so this one has to be 2. And then a and c are both logarithmic functions. So the 6 in front means it's increasing, so this one's an increasing logarithmic, versus a decreasing is the -2 in front, so that has to be number 4. Okay, and then this just summarizes what we just kind of covered. It shows you the x-intercept, the y-intercept, the end behavior, domain, range, just the general idea of it, and what an exponential should look like as well. So these kind of summarize the exponential lessons that we did, the characteristic, and this summarizes your logarithmic one. Thanks for listening. Hopefully I see you or talk to you guys soon. Have a good one, guys.